So graphing, we're going to do a weak base with a strong acid and 2 strongs. Remember, with the weaks, we still have the same 4 points, and we'll go through those as we go. With the strongs, as seen on the definitions, we only have the 3 points. So what we're going to do is work the first one. So we're going to titrate, as I said, a weak base with a strong acid. We're given the Kb. We're looking for the equivalence point, so we're taking the volume times the concentration. And we learn that we have 43.75 millimoles of the base. So to reach the equivalence point, moles of acid have to, or in this case base, have to equal moles of acid. So we have 43.75 millimoles of our acid, and we know that that is equal to a 0.05 molar times X milliliters. So we find out the equivalence point is 87.5 milliliters. We again will use that in both the second point and the third point. So now that we've got it done, and if you'll notice, I've gone ahead and labeled the pH units. I have not labeled the x-axis more than what I'm titrating with, and it's actually not HCl, it's HBr, which is still a strong acid, but let's go ahead and work the problem. So the first point is 0 milliliters of HBr. So it is a Kb problem, or a weak base. So our weak base is methylamine, and I'm going to call that Ma, plus water is going to produce methylamine with the proton, plus hydroxide. Now, there's going to be an extra step in this one at the beginning, because it's a base. So it's the Icd table. We're going to start with the amount we have, which is 0.35. 0 minus x plus x plus x, 0.35 minus x, x, and x. So our Kb is found to be x squared divided by 0.35 minus x, and remember, we were given our Kb value 4.8 times 10 to the minus 4th. So we have x squared plus 4.8 times 10 to the minus 4th x minus 1.68 times 10 to the minus 4th is equal to 0. So that means my x value is equal to 0.0127 molar, which, remember, this is the hydroxide ion concentration. So my pOH is equal to 1.896. So my pH is equal to 12.10. So my first point is 0 milliliters, 12.10. Now, remember, this is a weak base, so we're starting with a high pH and working down. This is the first point. The second point is the midpoint of the buffer zone. So, because this is a weak base, then the pOH is equal to the pKb. So, which is equal to 3.36, which means my pH is equal to 10.6. I'm sorry, that was 3.2. So this is 6.8. Alright, so that is our pH. But our volume, remember, is equal to half of the equivalence point. which means it's half of, what was that? The equivalence point was 87.5 milliliters. Therefore, our volume at the midpoint is half of that, which is 43.75 milliliters. So our point here for our volume is 43.75 milliliters of the acid, and our pH is 10.68. Now, much like the previous one where we started low and we keep going up, this one was starting high and we keep going down. So we got the first 2 points, so we need our third point. Our third point is at the equivalence point, which means it is our salt, which means it's a Ka problem. Because at this point, what has happened is we have taken all of the H plus from the HBr, reacted it with the methylamine to produce just the acidic salt of it. Okay? Which means that if we started with how many millimoles? 43.75. Then we are going to convert it to the salt. But we have to have a volume so that we can find a molarity. So we started off with 125 milliliters here. We added 87.5 milliliters here. So our new volume, so our volume total comes out equal to 212.5 milliliters, which means our concentration is 0.20588 molar. Okay, so if we're looking at it is MaH plus dissociating into H plus Ma. And initially we're going to have 0.20588 here, 0, 0. Changes minus x plus x plus x. Our equilibrium value is 0.20588 minus x, x, and x. So I'm just going to continue down over here, and I'll just do the strong in the middle. Okay, so we have a Ka here, and it's x squared divided by 0.20588 minus x. Now remember, we get our Ka from Kw divided by Kb. And remember, in this case, our Kb was 4.8 times 10 to the minus 4. So our Ka value comes out equal to 2.083 times 10 to the minus 11th. So we end up with x squared plus 2.083 times 10 to the minus 11th minus 4.289 times 10 to the minus 12th is equal to 0. So x comes out equal to 2.0710 times 10 to the minus 6. Now in this case, this is our H plus concentration. Therefore, we can just take the negative log of it, and we get a pH of 5.68. So this point at the equivalence point is 87.5 milliliters of the acid added with 5.68 pH unit. And again, we're still dropping, which is what we would expect considering what we have. Okay? And so let's go ahead and do our strong acid. Now remember, there are two ways. So the first one is and I'll call it try one. We're going to pick 108 milliliters of strong acid added. If we do that, we end up with, multiplying it by the molarity, we added a total of 54 millimoles of our acid. We used up 43.75 millimoles of our weak base. So we are left with a total of 10.25 millimoles of strong acid. Now, if you look at it, we started with 125 milliliters, and we added 108, so our new volume comes out equal to 233. So we have 233 milliliters, which means we end up with 0.04399 molar. Again, this is an H plus value, so our pH is equal to 1.36. Okay? So on this one, we would have 108 milliliters added to 1.36 is our pH. Or, try 2, we assume at infinity added, we achieve the strong pH. So we would take the negative log of our 0.50 molar, which is equal to 0.30 is my pH. So this point would be infinity versus 1. Whoops, that was the previous one. 0.30 pH. Okay, so the bottom line is that 1.36 versus 30, they're both pretty strong. Now, before we proceed any farther and graph this thing, let's go look at our equivalence point is 5.68. So if we go forward to, our indicator properties, we're looking for anything that has a pH of 5.68. So here's this range would work for the weak base. 5.68 wouldn't work up there, wouldn't work up there, so that's the one. So even though the middle is 5, it goes all the way up to 6.3. So we're going to go with methyl red. So if we were looking for the indicator here, we would say the indicator is methyl red. So if we were to graph that, again we have methyl red indicator. What we would do is we would graph our first point as 0 milliliters added and 12.10. So 12.10 is about right here. So we'd have 0 milliliters and 12.01 pH. Our second point comes at 43.75. Oh, that means I got to go down here and do this. Well, this one's kind of hard, so I thought about it. And so I've got this one set up like this. Okay? With 10 points per run. So if we added 43.75, so that's, and we're at 10.68, so 10.68, somewhere around here. Now these are kind of hard to graph, so that's why if you put in your points, you're okay. 10.68 pH. Okay, our next one is our equivalence point, which is 87.5. Whoops. Which, if we do that one, that's about 5.68. So 87.5, 5.68. So somewhere around here. So this one is 87.5 and 5.68 is my pH, my milliliters. And then my last point, we can use either one. And if we want to go with the last one, we use the infinity. So on this one, we'll use 108. So 108 would be about right here. And our pH is 1.3. So somewhere around here. So this point is 108 and milliliters. And a pH of 1.36. So again, when we graph it, this is the inverse of what we did before. We'll have a rise, and we kind of level off. It's not flat, but it's level until we get to the equivalence point, and then we're going to shoot down in this case, and then we're going to shoot over. Now, you can stop at this point. Now, I'm using a pen. Y'all are using a pencil, so you can make it prettier, but this is basically what it's going to look like. And we've already done the indicator, so we are good to go on that one. Okay, now, just because we want to round it out, we're going to do a strong acid with a strong base. Okay, now I've already put the pH units in here, but we have 1.2 molar of nitric acid is titrated. We know that this is our acid here. So the millimoles of acid is equal to 85 milliliters times 1.2 molar, which comes out equal to 102 millimoles. Now, because I did something goofy earlier, I'm going to go ahead and check my math. Yes, okay. This is my acid. Now, on this problem, some of you may have realized that this is nitric acid, but it's reacting with calcium hydroxide to produce calcium nitrate plus water, H2O. So what we have to do is that we've got to have two of these. We end up with two waters. So this is actually not a 1-to-1. So for the equivalence point, I have to calculate the moles of the base. Okay, so we know it's going to be 102 millimoles to reach the equivalence point. But if we look at our concentration, we know that we have, that's the base. We have, where's our 8.85 millimoles of the base per 1 milliliter of the base. But we know that there is 1 millimole of the base per 2 millimoles of the acid. So we actually end up with needing 60 milliliters for the equivalence point. That's where our moles of acid is equal to moles of base. Now here's the beauty of this one, is this is a strong, so the equivalence point has a pH equal to 7. So I can go ahead and put this one in. Well, because of my scale, I'll go ahead and do 5. So that's 10, 20, 30, 40, 50, 60, 70, 80, etc. So I know that at 60 milliliters, I'm going to have a pH of 7. So there's my middle point there. Now, unlike weaks, there is no buffer zone with strongs. So our first point is the strong acid. So the pH is going to be equal to the negative log of the 1.2 molar, which comes out to be equal to a negative 0.07918 pH. Now, again, you're not really supposed to have negative, but we'll just go with it. So this point is 0 milliliter, negative 0.07879 pH. Okay, that's point 2. Point 1, there's no buffer zone, so point 2 is at the equivalence point. We've already calculated that it's 60 milliliters of base, and since it's strong, the pH will be 7 because it's strong. Strong. The third point is the strong base. So again, there are two ways to do this. I went ahead and said, okay, we're going to add 80 milliliters of base, which gives us 68 millimoles times 2. So that's 136 millimoles of the hydroxide. Remember 2 because there are 2 OH groups, minus the number of millimoles of acid, which results in 34 millimoles divided by my new volume, which is 165 milliliters, because we used 80 milliliters of base, plus we originally had 85 milliliters of the acid. So the total is 165 milliliters total, which gives us a concentration of 0.2061 molar. But this, remember, is hydroxide. So the pOH is equal to 0.686. So my pH is equal to 13.31. So on this point, we're dealing with 80 milliliters and 13.31 pH. Now, we don't have to do anything else because this will give us our value. So our first point was over here was 0, and it was a negative, so we'll just go with 0 milliliters and negative 0.079 pH. The second one is 60 milliliters, 7 pH. Third one we used 80 milliliters, so we're going to come up here, and we got 13.31. So this is 80 milliliters, 13.31 pH. So on this one, it just rises. You can actually use this a straight edge if you wanted, and go straight up and then over. And again, it's kind of messy. Last thing is the indicator. So on this one, we need one that has a pH of 7. This will work for the strong. This one will actually work for the strong because it's close enough, because there's such a huge inflection. Phenolphthalein will work for the strong. Thymol blue would probably work, but I'd rather not. So it's bromethymol blue, metacresol purple, and phenolphthalein. So we could use as our indicator, we could use phenolphthalein, bromethymol blue, remember the next one, so I'll go look. I'm going to put metacresal purple. Or metacresal purple. Now, you're not responsible for all three. You're only responsible for one. So you could do or for that one. Okay? Now, you may be asked a question like this on the test. Most likely, I'll stick with the week. The only other thing I want you to go back and look at, if you've still got your data, is your diprotic acid. You have one inflection. That's the first equivalence point, second equivalence point, and 2 buffer zones. So you'll see this. I won't have you graph one of these, but you should be able to go back and look at your titration graphs and see it. Again, we are done now with all the titration stuff. So the first part of Chapter 17 is what is on the first exam, part of the exam. So I'll get, this will be posted, and your exam is posted on your syllabus. So go ahead and be looking over these and ask me any questions as we go.